Okay, let's continue on the exercise 7. But question number C, he evaluate the double integrals by changing to polar coordinates. Okay, expression is given double integral 5dA, whereas dAu is r d theta as two polar coordinates. And as repeated lots of time, to find limits, you need to know how to sketch first. By the sketching, you can determine the limit. So to sketch, the first equation is given here. In the region is enclosed outside this circle and the first circle and inside the second circle here. So let's sketch both circle. So the circle number 1, let's see the circle, I rename it as circle number 1. Okay, the circle is center 0 0, center 0 0, and the radius is 3. The radius is 3. For second circle, the center is at 0 3, 0 3, and the radius is 3. How to know the center is 0 3? Please compare with the formula of circle, which is x minus a squared plus y minus b squared is equal to r squared. So since negative here, this is also negative, so b is equal to 3. So this is b equal to 3. A, since there's no a inside here, so a is 0. So this is coordinate for the center. Okay, let's sketch the first one. The first circle, center 0 0 is here. Is here. So we want to sketch the circle center 0 0. Okay, you get center circle here, and then you label the radius is 3. So I get the coordinates here 3 3. Okay, next continue with the second circle. The second circle, center 0 3. 0 3 is here, so this is center 0 3. So center 0 3 and the radius is 3 units, so means that it will touch the center, the center or the origin coordinate here. So let's sketch the circle. You will get something like this. Okay, so this is your circle. Okay, suppose your circle both have the same side because both have the same radius. Okay, let's shade the regions. The region, if you see here, the region is said that outside the first circle and inside the second circle. So outside this circle is here. So inside the second circle is here. So means that your region located at this here. Okay, so let's shaded the region. So this is your region, just shaded it. Okay, don't forget to label. This is region R, region R. So this is region R. Okay, to find limits, okay, we rewrite the expression first. The expression is double integral 5 dA. So your dA in polar is r d theta. So to find limits, as I mentioned, it's from inside to outside. The inside circle, inside curve, you will meet this curve first, which means that this is the first circle. Which is x squared plus y squared equal to 9. Okay, this is x squared plus y squared equal to 9. Change it to polar because we want in terms of r. So x squared plus y squared is r squared equal to 9. R equal to 3. So here r equal to 3 as inside, or as the lower limit, and the upper limits you will make the second circle, which is the blue one. The second circle equation is x squared plus y minus 3 squared equal to 9. Okay, since we need in term of polar r, so change into polar r by expanding first at y squared minus 6y plus 9 equal to 9, and then rearrange x squared plus y squared minus 6y equal to 0. 9 bring to the other side, become minus, so 9 minus 9 is 0. Now x squared plus y squared is r squared minus 6y is r sine theta equal to 0. Next, r squared bring this part to the right hand side, it becomes 6r sine theta. So r, you can bring this r to the other side, become division, r squared divide with r, you get r itself. So it's like you can cancel this one, so you will have 6r, r equal to r equal to 6 sine theta. Okay, r here you can cancel out. Okay, continue. So your r is equal to, on the upper limit, you will get r equal to 6 sine theta. Next, we need to find the limits for angle. So your curve is here until here, shaded until when, might be until half, but we have until end here. So the angle will be from here to here. See the intersection point here? So we need to find the intersection angle for here. To find intersection, you need to solve simultaneous between two equations. So solve simultaneous between these two equations, you will get the intersection angle. So intersection angle, I write down. Let's say I do purple. Okay, intersection angle is solve simultaneously by equation of 1 and 2. So if I name this one as equation 1, this one as equation 2. So equation 1 you put into 2, equation 1 you put into equation 2, r is equal to 3. So you will have 6 sine theta is equal to 3. Sine theta is equal to 3 divided by 6, you will get 1 over 2. Theta itself is equal to sine inverse 1 over 2. For inverse, please set your calculator to mode degree so that you will get the degree first, which is 30 degree. Then you change to polar, which is pi over 6. If you put as mode radian, you will get decimal places in the calculator. So we try to avoid decimal places. You get the degree first, then change into polar. Okay, polar, change into radian. Okay, continue. So the angle here is pi over 6. Okay, so we start. Okay, from here to here is pi over 6. Okay, to make it clear, I sketch this one. So here, from here to here, okay, I get from here to here, this is pi over 6. Okay, so the bottom limit is pi over 6. Next, the limits for here. Okay, the limits for here, you need to sketch from here, I use green, to here, because your angle always start at the x positive here. So you need to find angle from here to here, because the angle start from here to here. So what is the angle from here? Since we have already this value, this angle, so we can determine this value. If this is pi over 6, of course this is pi over 6. So you can see what is the angle for here, because this is at 180 degrees line. So to find angle here is pi minus pi over 6. You will get 5 pi over 6. So here you have 5 pi over 6. You will get angle for the green one. Okay. Next. So you already have your expression. Now just solve until the end. Okay, to solve this one, Choose that color. Okay, integrate 5r to respect to dr, so you have r squared over 2 from 3 to 6 sine theta. And the outside limit, since we not do the operation yet, so please do copy here until you do the operation. So 5 over 2, I take it out, I put the limit inside, so 6 squared become 36 sine squared theta minus 3 power of 2, you get 9. Okay, and the outside limit, just copy. Okay, next I simplify, so I get so let's simplify. 36 times with 5 divide with 2, you get 90. So I expand it, I get 90 sine squared theta minus 45 over 2. So integrate from pi over 6 until 5 pi over 6 is d theta. So to integrate this one, to integrate sine squared theta is not sine cube theta over 3. This is definitely wrong. This is only valid for variable like x or x squared. So you have x squared. If you integrate, you have x cube over 3. This is valid only polynomial only for 3. Go. Oh, this one you need some method. Either might be substitution or might be by part. However, substitution cannot be used. Substitution, you need the partner of cos theta, then you can substitute. There's no cos here, so it cannot be substitute. So for by part you need a combination of loped, logarithm, polynomial, exponential, trigo. This one is only trigo, so you still cannot use by part as well. So in this case, you need to use trigo identity that given in the exam, so that you can change into the other form. So to change to the other form, 19 sine is sine squared in the appendix or in the trigonometry identity. Sine squared theta is 1 minus cos 2 theta over 2. Identity, please note that identity is not you not integrate yet, you just change the form first. So since it's not integrate yet, please do copy the integration symbol first, d theta. Okay, minus 45 over 2. Now I want to integrate this expression. Okay, this equation. So integrate 90 divide with 2. I get 45. And then I expand, then I integrate. So I have 45 theta minus 45. Integrate cos, I get sine 2 theta over differentiate inside here. So I get 2. And next, minus integrate 45 over 2, you get 45 over 2 theta. Okay, so now you already integrate. Then since you already integrate, so this symbol and this symbol is cancelled lah, because the operation have been done. Okay, so from pi over 6 until 5 pi over 6, you can simplify. 45 minus 45 over 2, you get 45 over 2. So since this one minus with this one, 45 over 2, this one also for 45 over 2, so I factorize it out. So I will get this one, 1 minus sine 2 theta from pi over 6 until 5 pi over 6. Okay, so next, continue. You put the value inside here. Upper limit minus with lower limit. So you will get, okay, so use your calculator. You will get approximately negative 86.09503 radian year Make sure you use calculator mode. Radian. If you want to use to press as pi. If you don't want to press as pi, you have to press as 180 degrees. So you can use the mode degree. So you just use mode radian. Easy. So this is the final answer. Okay. Next, I leave you with intensive practice 6. Question 2B, page 202. You can pause this video to solve this one. I will discuss it in tutorial class, online class, Webex. So try this one. The limits is actually given the questions actually want to show the limits, and actually if the question asks you to show, means that they give you already the answer. You just need to prove this one, and then you just evaluate. This intensive practice is quite similar with this example 7C, only that is easier because the graph is already given. You just change these two into polar form, and you will get the limit. After you get limit, just evaluate the formula. So it's just similar. You can try it. I will discuss it at the class. Thank you.